Hey, what's going on, guys? Let's do this problem right here. The question is asking if the work required to stretch a spring 6 inch beyond its natural length is 3 foot-pounds, how much work is needed to stretch it 11 inch beyond its natural length, right? So the main question is this one: how much work is needed to stretch from 11 inch to natural length? So let's create the equation for this one first and figure out what we need. So here we know that here, since we are dealing with spring, we have to use the Hooke's law. So Hooke's law is basically W is equal to integral a to b kx dx. So this is a Hooke's law equation. Now we have to know the spring constant and we have to know the limits of integration. We know the limits of integration, that's not a problem. It's saying natural length, so whenever we have natural length we also always take that one as 0. So this is going to be 0, and 11 inch mean since we are doing this one in foot-pounds, we know that 1 feet is equal to 12 inch, right? 12 inch. So we had to divide this 11 by 12 in order to convert this one into feet. So the upper limits of integration is going to be 11 over 12 feet, right? Same as 11 inch. If we convert into feet, we have to divide by 12. Now we have kx dx. Now in order to find this work, we need k. So that's why we are going to use the initial information. Initially they have given that to stretch 6 inch from natural length, it requires 3 foot-pounds work. Foot-pounds is same as joule, it's a unit for work. So here 3 foot-pounds required to stretch from natural to 6 inch. So let's calculate the k right here. The k is going to be same for this one. So if we find the k right here, we can plug it in this one and find this work. So let's put the equation for this work right here. So work is going to be same thing, integral a to b kx dx, and this is going from here, this is stretch from natural length 6 inch. So it's going from 0 to 6 inch. 6 inches basically 6 divided by 12, we can put 1 over 2, right? So 0 to 1 over 2 kx dx. K is what we are trying to find, and work is already provided, that is 3 foot-pounds. And let's do the integration. So this is going to be 3 is equal to kx square divided by 2, going from 0 to half, right? Now let's take the constants out. So this is going to be 3 is equal to k divided by 2 x square, going from 0 to half. Now if we plug half for this x square, let's see what happens. 3 is equal to k divided by 2 half square minus 0, because the lower limits of integration is 0. So if we substitute 0 for x value, that's going to be 0. So we have this half square right here, and let's simplify this one. 3 is equal to k divided by 2 times 1 over 4, and that's going to give us, this is 8, right? K over 8. If we bring it to the other side, 3 times 2 times 4, that's going to give us 6 times 4, 24. So spring constant is 24. Now we have found the spring constant. Now we have to calculate the work. Calculating the work is the main question. Now we created the equation already. Now all we have to do is plug this k and find the work. Let's go ahead and find it. So here we have 0 to 11 over 12, and let's plug the spring constant. So 0 to 11 over 12, and spring constant is 24 x dx. Now let's do the integration. If we integrate this one, this is going to give us 24 x square divided by 2, and that's going from 0 to 11 over 12. Now we can go ahead and plug, this is basically 12, and 12, go ahead and plug 11 over 12 for x values. So this is going to be 11 over 12 square minus 0. Lower limits of integration is 0, so we just subtract 0. So here we are going to have this one. Let's simplify this one. This is going to be 11 times 11 square over 12 square, and this square and this 12 can be cancelled, and this is going to give us 121 divided by 12, and that is equal to almost 10.08 foot-pounds. and that's going to be the final answer. I hope you guys find this video helpful. See you next time.